So if I have this system based on operators and I have operator, 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 what am I saying? I'm trying to break down operators into objects as one possibility for finding some way to create this. So I'm going to let X be a resonance, call it X maps to where the X is left behind. That's what this bar means. Bar, arrow means maps to, but the element is dropped. Alpha equals alpha 1, comma alpha 2, alpha 3. Then I would see, then in my mind's eye, I can see that there might be these resonances right here. Alpha, each operator points to some object from the resonance alpha, and that is equal to all of those operators pointing into some object in the resonance alpha. Note that here I assert that the resonance is such that all combinations of the elements of the set that define the resonance are possible for any arrangement of the alpha unless it is specified in one of these three ways. And the reason I only show you three here, it's A1, because they're, without loss of generality, the only forms given A1, A2, and A3 are all different, but they could be the same. The thing we just note about a resonance is that resonances appear in two places at a time. The idea is that resonances must appear in multiple places. So generally, instead of writing numbers as subscripts, we just use our diagrams and write A-A, which implies, A line A, which sort of implies that we're given some set alpha, and that is a set of solutions. So alpha is a set, alpha equals alpha 1, comma alpha 2, comma alpha dot 3, dot, dot, dot. But in this set, alpha 1 may actually be exactly equal to, say, alpha sub n. Now, this set must have some properties to it. And so those properties are based on relations of what you might call resonant forms. If a resonance is so that the elements of the set A equals A sub 1 through A sub n are hyperresonances, then I'm going to define the collapse into objects in a few different ways that might be possible. One of them is simply that A sub 1 equals A sub 1 operating with A sub 1. So A sub 1 appears twice and it operates on itself by some operation. We have recursive, A sub 1 equals A sub 1 taking itself over and over until it collapses to some delta. Again, delta are of type discord. Or I have repetitive where A sub 1 equals A sub 1, then we operate on A sub 1, then we operate on A sub 1, and then we finally operate on some delta. And I imagine this can have any ordering as the base assumption to cover the most possibilities. Or we make A sub 1 appear in two places at the same time by taking an object operating on A sub 1. So A sub 1 just takes some thing that is an object and it returns a sub 1, thus satisfying the idea that resonances must appear in multiple places at the same time in a recursive way. And that's all for now.